Welcome to The Explainer. So, you're getting ready for a data engineering interview. We all know it can be a real beast, but today, we're going to tame it. We are going to break down the absolute must-know topics into a simple, strategic plan, so you can walk in feeling confident and walk out with that job offer.
Yeah, let's be real for a second. These interviews can feel, well, pretty overwhelming. It seems like you're supposed to know absolutely everything, right? From super high-level architecture and big data frameworks, all the way down to the nitty-gritty of specific cloud services and tricky SQL puzzles. It's a lot to cover.
But hey, don't sweat it. That's exactly why we're here. We're going to turn all that confusion into a clear, structured path forward. Think of this as your personal guide to building up that confidence so you can walk into that room ready to absolutely nail it.
So here's our game plan. We've broken this down into 5 key levels you've got to master. First, we'll cover the core engineering concepts. Then we'll dive into taming big data with Spark. After that, it's all about mastering the AWS cloud, followed by conquering advanced SQL. And finally, we'll wrap it all up with your interview-winning strategy. You ready? Let's do this.
All right, let's kick things off with Level 1, Core Concepts. Seriously, these are the big picture ideas, the architectural patterns that are the absolute bedrock of all modern data engineering. Getting these right isn't just a good idea, it's non-negotiable. First up, a question you're almost guaranteed to get. What's the difference between a data warehouse and a data lake? Well, think of a data warehouse like a pristine library. Everything is structured, cataloged, and ready for you to find a specific answer. A data lake, on the other hand, that's more like a giant reservoir. You dump everything in there, all your raw data in its original format. It gives you maximum flexibility to figure out how to structure and use it later on. So how in the world do you keep that data lake from just turning into a messy data swamp? Well, a really popular pattern is the Medallion Architecture. It's a pretty straightforward 3-step process. Data lands totally raw in the bronze layer. Then it gets cleaned up and structured in the silver layer to become a reliable single source of truth. And finally, in the gold layer, it gets aggregated and prepared for business users to use in their dashboards and reports. It's all about refining your data step by step.
Okay, now for a fundamental law of distributed systems, the CAP theorem. And here's the absolute key takeaway. Network failures or partitions, they're gonna happen. It's a fact of life. You can't avoid them. And because of that, engineers are forced into a really tough choice between the other 2 guarantees. Do you want perfect consistency, where every user sees the exact same data at the exact same time, or do you want 100% availability, where the system always answers even if some data is a tiny bit stale? You can't have both. You have to pick one.
So what happens when your data changes over time? Like when a customer moves to a new address. That's where slowly changing dimensions, or SCDs, come into play. Now, the one you absolutely have to know for an interview is Type 2. Here's the deal. Instead of just overwriting the old address, you add a brand new row for the new one and you mark the old one as inactive. Why? Because this way, you keep a complete historical record of every change, which is totally critical for accurate analytics.
Time to level up. Let's get into Level 2, taming big data. And really, you can't talk about big data without talking about Apache Spark. It is the undisputed king of large-scale data processing, and you've got to understand how this thing really works under the hood. So why did Spark totally dominate older systems like Hadoop MapReduce? The answer really comes down to one word: memory. See, MapReduce was painfully slow because after every single step, it had to write all the intermediate results to a physical disk. Spark completely changed the game by doing almost all of its work in memory, in RAM, which is just worlds faster. And that brings us to one of Spark's real superpowers, something called lazy evaluation. It's brilliant. When you write code telling Spark what to do, it doesn't actually do anything yet. Instead, it just quietly builds a logical plan, kind of like a blueprint of all the steps you asked for. It's only when you call an action, like saving the file, that Spark's optimizer looks at the entire blueprint and figures out the absolute fastest, most efficient way to get the job done.
Now, inside that plan, there are really 2 types of operations you need to know: narrow and wide transformations. And the main difference is something called the shuffle. Narrow transformations are awesome. They're fast and cheap because all the data can be processed on a single machine. But wide transformations, they're expensive. They force Spark to shuffle huge amounts of data across the network between all the different machines. That shuffle is a major performance bottleneck that you always want to avoid if you can.
All right, let's keep moving. On to Level 3, mastering the AWS cloud. Look, AWS is the dominant player in the data world, period. So knowing the key services is important, but you know what's even more important? Understanding the trade-offs between them. That's what interviewers are really listening for.
And here's a classic comparison they'll throw at you: AWS Glue versus Amazon EMR. The easiest way to think about it is this. You use Glue when you want a completely serverless, hands-off service for your standard, everyday ETL jobs. You reach for EMR when you need a super powerful, highly customized cluster where you have total control over all the frameworks and configurations. So it really boils down to a trade-off: convenience versus control.
If you're using Python to work with AWS, you are definitely going to be using Bodo 3. And it gives you two different ways to talk to AWS services. The client interface is low-level. It's a direct line to the raw AWS API. It's really powerful, but it can be a little clunky. Then you have the resource interface, which is a higher-level, more object-oriented way of doing things that can make your code way cleaner and just feel more natural in Python.
You know, building data pipelines is one thing, but debugging them when they inevitably break, that's a whole other skill. Interviewers want to see that you have that practical, hands-on experience. So for a service like AWS Glue, this means you should be able to talk about common issues, like getting out-of-memory errors from a massive data shuffle, or how job bookmarks can sometimes cause you to process duplicate data. Knowing these things shows you've actually been in the trenches.
Let's tackle level 4, advanced SQL. And let me be perfectly clear about this. Having strong SQL skills is 100% non-negotiable for a data engineer. Interviewers just love to throw out little puzzles, like the one we're about to see, to test if your knowledge goes beyond a simple select statement.
So here's that classic puzzle. An interviewer might ask you, how would you rank all of our employees by their salary, but you have to do it separately within each department? Now, you could try to solve this with some really messy, complicated self-joins, but there's a much, much more elegant way to do it.
And that elegant solution is window functions. This is the key. They let you perform calculations across a set of related rows, a window of data, without squashing everything down into a single row like a group by would. The real magic is that partition by clause. It tells the rank function to restart its counting for every single department, solving the puzzle perfectly and efficiently.
But a really sharp interviewer won't stop there. They might ask a follow-up like, okay, so what's the difference between rank, dense rank, and row number? And it all comes down to how they handle ties. See, if two people have the same salary, rank will actually create a gap in the numbers, jumping from 2 to 4. But dense rank won't leave a gap. It'll go from 2 right to 3. Knowing these subtle differences and which one to use when is a true mark of a senior-level candidate.
And that brings us to our fifth and final level, the winning strategy. Because look, getting the right technical answer, that's only half the battle. How you communicate your thought process and show that you have a mature engineering mindset, that is what really seals the deal.
So it's not enough to just say, oh, I'd use Spark. You have to explain why you'd use Spark. You need to talk about the trade-offs of your approach compared to another one. Mention specific best practices like partition pruning to show that you're always thinking about performance. And always acknowledge real-world constraints like cost and security. This is what elevates your answer from just being a fact to being a well-reasoned engineering decision.
And as you go through your interview, try to always bring it back to this core purpose. Because at the end of the day, all of these complex tools and fancy architectures, they all serve one simple goal: to take raw, messy, unreliable data and transform it methodically into a high-quality, trustworthy asset that the business can actually depend on to make critical decisions. So I'll leave you with this final thought to chew on. As AI and automation get better and better at doing the routine parts of our jobs, like building basic pipelines, what becomes the most valuable human skill for a data engineer? I think it's the ability to design robust architectures, to solve ambiguous business problems, and to apply strategic thinking. Those are the skills that go way beyond just writing code. And I believe that's the future of this entire field.